In this video, I'm going to explain you some of the most important theorems that you can see in M.Sc Topology. Okay, so here I'm going to start with this theorem 18.1. Okay, you can see this theorem in second unit actually. Okay, so theorem 18.1. Okay, let us read the statement. Let x and y be the topological spaces. They are given you two topological spaces and a function. Here you have a function. They are defining using this topological. In this topological spaces, they are defining a function that is f from x to y. Then the following are equivalent. If these two conditions are there, then you have to prove the following conditions are equivalent. So equivalent, how you will prove that equivalent condition? That is, you have to prove 1 implies 2, 2 implies 3, right? That is how you are going to prove this theorem, okay? 1 implies 2. In this theorem, you are going to prove 1 implies 2, 2 implies 3, 3 implies again 1, and 1 implies 4, and 4 implies 1. That is how you are going to prove these conditions, okay? So here, let's start with the first. The first point here given is f is continuous, and the second one is for every subset a of x, one has f of a closure contained in f of a the whole closure. Okay, that is what the second point they have given here. So here first you are assuming the first part, f is continuous, and you are proving for every subset a of capital X, one has f of a closure contained in f of a the whole closure. Okay, you are copying it from the question, right? So here is no any other difficulties to write these two lines for this proof, right? Just copying. Okay, now first you are going to prove if x belongs to a bar, that is a closure, then f of x belongs to f of a the whole closure. So that is what you are going to prove now. If you proved this, then obviously this condition will be proved. Okay, that is what they are talking about. So here, if x belongs to a bar, then f of x belongs to f of a the whole closure. That is what we are going to prove now. So to prove that, what you are going to do is, you are taking a neighborhood, that is V. This neighbor, you are taking this neighborhood of the point f of x. Okay, with this point f of x, you are taking a neighborhood, and that neighborhood is V. Let V be the neighborhood of f of x. Okay, so before that, you keep this in your mind. Okay, here they are given you a function, and what you are going to do is, you are taking a point from y, that is f of x, and for this f of x, you are taking a neighborhood, and that is V. Okay, so here in the first line you are writing V is a neighborhood of f of x. Neighborhood means every neighborhood is an open set. There is a theorem like that. Okay, so here this neighborhood is an open set. Also, you know that inverse image of every open set is open. So inverse image, okay, this is open, V is open, right? V is an open. So inverse image of this will be open in X. V is from Y, V is from Y. The inverse image of V will be in X. Okay, that is what the meaning. Here they are talking. So that is what you are writing here also. Since f is continuous, inverse image of every, by the definition of continuous, you can say this. Okay, inverse image of every open set is open. Okay, in X here. Inverse image will be open here. Okay, yeah, I hope you can understand the point what I am trying to convey. Okay, since f is continuous, inverse image of every open set is open, so inverse image of this will be open. Okay, that contains the point x. The point is here. Okay, x point is in the set, in the topological space x. So there is an inverse image of this V, that is f inverse of V, and this is also an open set, and this open set contains the point this. Okay, so if you can remember this, then the probability of forgetting the steps will get decreased. Okay, that is why I'm showing you this figure here. Yeah, this is not a figure, a hint. You can consider this as a hint. Okay, can everything visible? Okay. Therefore, inverse image of every therefore, f inverse of v is an open set containing the point x. Okay, since x belongs to a bar, in the first line here you are writing, right? Since x belongs to a bar, by a theorem, okay, there is a theorem. You can refer 17.5. I'm not going to show that here now. So you are writing this sentence by a previous theorem. Okay, so the theorem, by that theorem, what you are writing is, since x belongs to a bar, this f inverse of v, here a sentence will come. I did not write the sentence here, because when you write the sentence, when I write the sentence like that, then I will forget. Okay, studying with these things, I don't forget. That is why I'm writing like this. Okay, but I will tell you the sentence. Okay, you can listen that, and when you are writing, you can write with that sentence, because this is my hint paper. Okay, hint, not hint. Okay, this I wrote based on my understanding, to understand more. Okay, so that is why. Okay, since x belongs to a bar, f inverse of v intersect a. Okay, this is, consider this as f inverse of v, just to make learning easy. I'm doing this. F inverse of, here you have an open set, right? So that in f inverse of v intersect a at the point y. Okay, so therefore from this you can say v intersect f of a at the point f of y. Okay, these are the two sentences that you have to write here. Therefore from this you can say f of x belongs to, okay, they asked you to prove this, right? That condition you have proved. F of x belongs to f of a the whole bar. If you ask me how you are saying that, sorry, I have no answer for the question. Okay, f of x, I frankly say, if I don't know the reason behind it, then I will say, okay, I don't want to adjust it. Okay, f of x belongs to f of a the whole closure. Therefore you can write, so you proved this, right? In the first line, if I told you, if you proved this, then obviously this condition will be proved. So that is how here this condition you have proved here, so that obviously our to prove condition is also proved. That is how you are writing. Therefore f of a closure contained in f of a the whole closure. That is, in the place of a, here I will tell you how this from this step to this step, how it came. I will tell you. Okay, here f of x belongs to f of a the whole closure, right? So we know that x belongs to a closure. So in the place of x, here you are substituting a closure. Okay, that is what happening here. So I hope you understand one implies two. Now in the next video I will explain you what 2 implies 3. Okay, if I post all the parts in one video, the video will be very lengthy. Okay, it will be very difficult to upload that video, that kind of lengthy video. So I don't want to do that. So 2 implies 3 part I will upload in the next video.